that I can use just like our translate method. Now you might hear people say methods or functions in Unity and in C#. They're essentially the same thing, but a lot of people just tend to call things methods when you're using these kinds of statements here that have parentheses. Now, you can think of all of these different words very similar to how you would think of a dictionary. And so a dictionary helps you understand a word that you're looking for. In this case, in programming, this is called documentation. And so our documentation, or our dictionary, tells us all of the different words, all of the different actions that we can perform with our transform component here. So I'll use translate again. And now, if we push that dictionary analogy even further, so we have the word translate. And if I use an open parentheses, you'll see that now my IDE suggests different parameters, different pieces of information that I can tell it to use to do something. You can think of this very similar to a thesaurus and synonyms, where many different words have a similar meaning. In this case, we have many different kinds of methods, and these methods all have different ways that you can essentially do the same thing. So in this case, it's asking for a vector3 translation. Now, in order to get a vector3, I can actually just type vector3. And here, now, you can actually see we actually have a suggestion as to what a vector3 is, which is super helpful. So my IDE tells me that a vector3 is a representation of 3D vectors and points. What does that mean? Well, in fact, that 0, 0, 1 is just 3 dimensions of points, 3 different points that we use, a 0, and a 1. In fact, that 0, and that 1 all correlate to the position on our transform component. So we have the 0 on the x, the 0 on the y, and then our 1 is actually the z updating over time. We even have these vectors, these 3D points, in our obstacle with our position. You can see the 0, 0, and the 25. That's a vector 3. That's 3 different points that we're storing. So with that information, it's very helpful because we can actually just shorthand this bit of code that we wrote with 0, 0, 1. In fact, if we use dot and then forward, you can see that forward is actually just shorthand for writing 0, 0, 1. So that actually, can save us a lot of time, and especially is very helpful to making our code easier to understand. Because if I told a person to move something 0, 0, 1, they'd be like, I don't know what you're talking about. But if I tell them to move forward, they know the direction of forward. So this is how different keywords in programming can help make our lives easier, to make it easier to understand what is in front of us, but then also translate that into something that the computer can understand, in this case, the 0, 0, 1. So if we remove now our previous line of code, now we'll just make sure that we save. Always make sure you save before you go back into Unity. And now, in our player controller, you can see that our translate method has changed from 0, 0, 1 to this vector3 forward. And when I press play, our vehicle is still flying all the way off the screen. So, looks like our code did exactly what we wanted to do before, which is great. And it's easier to read. So what you're going to do in your player controller script, you're going to change your line of code from 0, 0, 1 to vector3 dot forward. Now it's your turn.
Okay, let's tweak the code. Oops. Um, that forward. Oops. still flies so fast. Oh, okay. And oh boy. Okay, and there we go. Done. This mark is completed. Let's slow this thing down, aka 5. Customize the vehicle speed. Right now, the speed of the vehicle is out of control. We need to change the code in order to adjust this. Customize the vehicle speed.
We've fixed our vehicle, so now it flies down the screen once again, extremely fast. At least our code is a bit more readable, but now we need to slow that vehicle down so it doesn't fly off into the distance. So in our player controller script, we're actually going to use a little bit of math in this method to be able to slow our vehicle down. So first what we're going to do is we're going to want to change the way that we move our vehicle. So currently the way this works is our update method is called every single frame. But depending on how powerful your computer is, you might get 20 frames in 1 second.
Sorry, I once again didn't know I was unmuted. Let's start it over.
We've fixed our vehicle, so now it flies down the screen once again, extremely fast. At least our code is a bit more readable, but now we need to slow that vehicle down so it doesn't just fly off into the distance. So in our player controller script, we're actually going to use a little bit of math in this method to be able to slow our vehicle down. So first what we're going to do is we're going to want to change the way that we move our vehicle. So currently the way this works is our update method is called every single frame, but depending on how powerful your computer is, you might get 20 frames in 1 second, you might get 60 frames in 1 second, and so really your player could move at varying speeds depending on what kind of device they're using. So we actually want to change that from updating every frame to updating over time every second. So the way that we do that first is by multiplying, and for a computer you should use the star symbol. So if you press shift on your 8 key, it'll create that star symbol, because actually if you press X and use the X key, it considers that an actual letter that it needs to know to use for a word. So we use the star symbol to tell us that we're multiplying something. And then what we'll actually do is we have a class already made to keep track of time, so we don't have to write a class ourselves. So that is called time with a capital T, and you can even see it highlights it in green. That way we know that this was a pre-made class. So now we're using time to keep track of our time, and we actually use delta time to get the change in time between all of our different frames. So now, using this bit of code, we can actually know when 1 second has actually elapsed versus 20 frames happening, 60 frames happening. Who knows? We can't control that. We can control how much time is actually passing. So if we go test this, we press play, and our vehicle is still flying down the road, and that's not what I wanted to happen. I forgot to save again. Okay, so back in the player controller, just make sure you save Control or Command S. That way it always updates the script in Unity. So now, when I press play, we should see our vehicle moving, albeit very slowly, but because of that little bit of code we added, we're actually now moving 1 meter a second. You can see, if you want to time it, it would probably be just about 1 unit every single second. So cool, now we have our vehicle moving by time. Granted, it's moving very slow, but we can fix that pretty easily. So what we're going to do in our player controller, we're just going to multiply by a random number using that star symbol. So we'll multiply by, say, 20. So it should move about 20 meters every second now. So now if I test and I press play, and I forgot to save again. Always remember to save. Now, when we press play, there you go. Now it's moving nowhere near as fast as before, but definitely not as slow either, which is great. As a fun little tidbit, the way that this formula actually works, this little equation that we have, so in fact, vector3.forward is storing a 0, a 0, and a 1. And so when you're actually multiplying it by the time and by 20, you're actually multiplying each of the different values. So first you multiply your 0 by time and by 20, which will always be 0. Then you multiply your y, which is 0, by time and 20, which is still 0. And then you multiply the z by time and by 20, which gets you 20 meters a second. So just a fun way to kind of see how the math works, and would definitely save a lot more time than just typing 0 times time dot delta time times 20, comma 0 times time dot delta time times 20 times 1 times time dot delta time times 20. So a really helpful way that, especially this shorthand, makes our lives even easier than before. So what you're going to do is, in your update method, you're going to change your transform.translate to just include a star symbol for multiply, and you're going to multiply your vector3.forward by time.delta time, and then you're going to multiply all of that by 20, so now it should move just about 20 meters a second, so that when you test your game, you press play. If you select the vehicle while it's moving, you can see the Z value changing, and if you used a stopwatch, I'm sure you could see that it probably moves just about 20 times every second. So, now it's your turn.
Okay. Alright, let's add the time. Okay. Time, delta time, 20s. Okay. Okay. No. Keep forgetting. 20. Okay. Double check. Okay. 2, 3, 4. Right. Back to the game. Alright.